Hi everyone, so this video is dedicated to exercise the normalization of database tables. So let's have a look on this part. Before that, we recall back the key terms and abbreviation under the normalization. So the first thing is the normalization itself. Please be reminded that the process of determining how much redundancy exists in a table is a normalization process. So under normalization, we have several stages of the normal form. So normal form is a special terms used under the normalization. So we have the first three normal form. There is the first normal form, second normal form, and also third normal form. And the special case of the normal form, we have the BCNF, Boy's Code normal form, and also fourth normal form. Okay. So what is a normalization? So this is a review question. What is a normalization? So the normalization is a technique used to design tables in which redundancies are minimized. So this is the way how the database structure is reviewed, checked, and then maybe required to be restructured when the design itself containing inconsistencies and it makes the data redundancies exist. So we want to reduce the data redundancies problem. So when is a table in first normal form? It is when all key attributes are defined and when all remaining attributes are dependent on the primary key. So the primary key, so this situation contains a partial dependencies and also transitive dependency. So this is what the first normal form should be. So in the first normal form, okay, you are required to identify or define the all key attributes and the remaining attributes are dependent on the primary key. So we have a functional. So defining the key and also the dependent attributes are be made under the functional dependencies. Okay, dependencies. So functional dependencies has two kinds. The first one is partial dependency. Second one is a transitive dependencies. So remember that the partial dependencies is the situation when the primary key define the dependent attributes, and transitive dependencies is defined when the non-primary key defining the attributes. So this is the situation. So remember again, when given the situation, so this you are given the structure, database structure. Okay, you are required to check, and then the first checking is for you to ensure this part have fulfilled the normalization. If not, then you are going to the first normal form state. And what are you going to do in the first normal form? So you are going to find the functional dependency. Okay, what to find? Find all the attributes that are related with either for the primary key or non-primary key. So this is the task in the first normal form. Okay. So when is a table in second normal form? So the table is in a second normal form when it is now in a first normal form and contains no partial dependencies. No partial dependencies. So remember again, in the first normal form, the situation is like this. Okay, given the schema or table. Okay, so you need to find or to identify the functional dependencies. This is, for example, functional dependencies. So when you find this one, so this your database now is in a first normal form. So proceeding to the second normal form, then you should ensure that there is no more partial dependency. No partial dependency. So this, if this is the key is a primary key, So you have a partial dependency. So how to make sure that there is no more partial dependencies? Okay, so we need to eliminate the this one by creating a new table. So create the new table. So how to eliminate the partial dependency? By creating the new table. So same goes when it is a table in a third normal form, it must be in a second normal form. That means that there is no more partial dependency, and also we need to remove the all the transitive dependencies, if any. So also the same, you need to create a new table to remove the transitive dependencies. Okay. Creating new table means that you are splitting the table, splitting the first normal form table or second normal form table. This one, for example. Okay, create new table. So in a larger perspective, it is actually like this. Okay, in the first normal form, all the tables are is given in this one, single or multiple table is also okay, because we want to identify the dependency, the functional dependencies, and then we are required to remove all the dependencies here. Okay, in during the lecture, okay, we use mostly the single table. Okay, we have like this, we have the single table in the first normal form, then we define the dependency. Okay, this is the example. Okay, and then when we proceed to the second normal form, okay, the actual task is actually to split. Okay, to split the table. This is for the example. So in the second normal form, now we have three table, for example. Okay, and then we proceed to the second normal form. Okay, and so on. Okay, so this is example for the single table in a first normal form. It is okay, we can have more table, okay, like this, in a first normal form, but remember that all of this is unstructured. Unstructured means it's not good, not in a good condition of the database structure. So yes, we always can do the same process. Okay, define the functional dependency. Okay, and then create a new table, create new primary key, and so on, when proceed to the second normal form and also third normal form. The process is the same, but except in the first normal form we have multiple table. Okay, so this is the situation. Again, I explained about the normalization. Okay, example, more example. Okay, so this given in the slide is the table 1. Table 1 shows the details of the patient dental appointments, okay, with these attributes, and also the data, the records is also provided. Okay, the question is now asking you to provide the examples of insertion, deletion, and modification anomalies. It is an update anomalies. Okay, so the suggested solution for this one is given, and you can try to read and get the hints behind the question and the solution given. So for the insertion anomalies, based on the given table, okay, to insert a new patient particular that makes an appointment with the designer doctor, we need to enter the correct detail. Yes, detail for the staff. So for example, to insert the details of new patient in new number, patient and appointment, okay, we must enter the correct details for the doctor, staff number, and also the dentist name, so that the patient details are consistent with values for the designated number. For example, S1011. Okay, it means that, okay, if you are having a new patient, for example here, Billy, for example, this is a new patient, so you need to insert the correct number for the staff number and also dentist name. Okay, so it means that you cannot add, okay, you cannot add as 1011 with other name. Okay, for example, Jimmy. Okay, because S1011 is dedicated for Tony Smith. Okay, Tony Smith. Okay, so if this is happening, so it is incorrect. Okay, so it means that we need to insert with the correct value. So to enter new patient data that doesn't have doctor to be assigned, we cannot insert null values for the primary key. For example, at that moment, you have a new patient to be inserted. For example, Sarah. Okay, Sarah, but you do not know the dentist name. You here is a staff, clerk or nurse. Okay, so you cannot insert the patient name without knowing the dentist name because it can be null. Okay, it can be null. So this is to shows the insertion anomalies. Okay, so from table here, you can see that there is a duplication here, redundancies. Okay, the Tony Smith appear 2 times, the dentist name appears 2 times. So this shows us that this table is not very well structured. Okay, even though looking at this one, looking at this structure of data, we have a staff number, dentist name, patient number, appointment date, time, surgery number. So all together is dumped into a single table. Okay, so if this is an appointment table, then patient name is not required. Dentist name also not required. Only the primary key or foreign key of staff number, patient number, appointment date, time, and surgery number is required. Okay, so we go to the deletion anomalies. If we want to delete a patient named Ian McKay, okay, like this one, okay, we have 2 records of the Ian McKay, okay, because the appointment date is first is in 3rd September and the other one is 12th September and the other one is 14th September, 2 days. Okay, so 2 records need to be deleted as in row 3 and 4 because there exist 2 records of the Ian McKay. So this anomaly was also obvious when we want to delete the dentist name. Multiple records needs to be deleted to maintain the data integrity. This means that actually we just want to delete Ian McKay, but there is 2 records there. So if we delete the Ian McKay, so 2 records will be deleted. Okay. So by deleting this one, by deleting the patient name Ian McKay means that we will delete the record of the appointment, patient appointment. Not for 1 but for 2 days. But sometimes the appointment records is still required. Okay, but okay, the other situation is like we want to delete the record of Ian McKay. And then there exists 2 records. So actually we want to just remove the first record, but we cannot. We must delete all the record relating to the Ian McKay. So this makes the deletion anomalies. This is happening when the table data is not very good. Okay, the third one is the modification anomalies. So with redundant data, when we want to change the value of one columns of a particular dentist, okay, for example, the dentist name, we must update all the dentist records that assigned to the particular patient Okay, otherwise the database will be inconsistent. So it means that if we want to modify the single data, we need to ensure that all data also must be updated. If not, then it makes a problem. Okay, so sometimes modifying or updating all the related data is not easy. Okay, because sometimes the data is split. Okay, and then we need to check all the tables. Okay, so this is tedious, and that's make the modification or updating part is difficult if the database table is unstructured. Okay, unstructured here means it's not a very good in a very good structure. Okay? Alright, so next is another exercise. Okay, given the table, okay, so you are required to describe and illustrate the process of normalization, the table shown in a figure 1 to the third normal form. So it means that given the table, you are required to explain the normalization process from first normal form to the third normal form. Okay, so remember to start with, you are required to either draw the dependency diagram, or you can just use the schema diagram. So this is the dependency diagram, or you can just list down the dependencies diagram using this one. For example, key, and then use the arrow, and this is the dependent. Okay, dependent. Okay, so this is the dependency diagram. Okay, and this is the schema. Okay, so to start with, you can either use either one to illustrate, or you can use both. It is okay. So given this, to proceed with the first normal form, we need to find the functional dependencies. But how to find it? Find the functional dependencies is always subjective. But the rule is it must reflect to the real world situation. Real world situation. So in this part, given the attributes and also the what is this? The record. Okay, so when we use this one to structure or to draw again, so you can do the like this. So this is the dependency diagram. Okay, you can write down the staff number, the dentist name, and so on. Okay, alright, so this is not in the first normal form yet. I just write down the dependency diagram later on to be used to define or to identify the functional dependencies. Functional dependencies. Okay. This is the dependency diagram. You can use either one or both illustration to illustrate the situation. So from here we have staff number, dentist name, patient number, patient name, appointment date, time, and also the surgery number. So this is the original data given. So to proceed with the first normal form, you are required to find the functional dependency. So from here we can check, okay, a staff number usually can define the dentist name, patient number, okay, can identify the patient name, and also appointment date time cannot be a key in a single situation. surgery number. Okay, so maybe we need to combine more than one key. For example, staff number, appointment date, time, okay, and also appointment time. Okay, these two to define the patient number and also the patient time. Okay, like this. Okay, then patient number, okay, patient name and also surgery number. Maybe patient name, patient number, patient name, because surgery number here we do not know how to connect the surgery number with the other, but logically surgery number has something to do with the patient, so maybe we can connect it at this moment. And then staff number, appointment date also can be used to be connected with the surgery number. Okay, staff number and also appointment date, okay, can be used to determine the surgery number. So this is other key. Okay, so the first three dependencies is obvious, but the rest maybe is not obvious. If lack of information is given, then we made the assumption. So this is again back to the note given, that how do you define the functional dependencies. It is subjective. Okay, sometimes more information is required. Okay, the more detailed the information given, the more we can find the easier we can detect or identify the dependencies. Okay, so in the examination, for example, if lack information is given, you may make assumption, or you just take out the obvious information. Okay, so it is the first normal form. Now we want to define which one is partial dependencies and which one is trustive dependencies. So based on my plain information, because not really much information is given, staff number is usually a primary key, right? It must be unique. And also the patient number, usually it is a unique key, unique. When it's unique, and then it can be regarded as a primary key. So same goes to the surgery number, but the rest is not. Okay, so when this one is defined as a primary key, so the relation, okay, connected to it will become the what? This one will be the partial dependencies, and also this one is partial dependencies. Okay, but the rest, okay, the rest is not, because one part is primary key, but the other is not. Okay, so this is a trustive dependencies, and also this is a trustive dependencies. Okay, so now we go to the second normal form. From this, okay, from the single table, okay, you are looking in the dependency diagram. Now we split the table, so we have the new table that is 3 staff number, defining the dentist name, staff number, appointment date, defining the surgery number, okay, and staff number, appointment date, and also appointment time, defining the patient number and patient name. This is the solution given, but from my point of overview, okay, my my version of second and F will be like this: staff number, define the dentist name. This is the solution I found in the book, okay, but this is my version. Staff number, defining the dentist name, and then patient number, defining patient name. Okay, patient name. So these two is a 2 and F, when the rest is not. Okay, so this is a second normal form. Then we proceed with the third normal form because we have the transitive diagram. So we repeat again the 1 and 2 here, and then we add up with the transitive dependencies, the new table. Okay, so for example, staff number, okay, this is okay, staff number, and appointment date, time, okay, defining the patient number and patient name, patient name, okay, and the rest. Okay, staff number, and appointment date, defining the surgery number. Okay, and then the rest is staff number, defining this name and this one. Okay, so this is my own version, but the rest, in the third normal form, we can reach the same solution. Okay, so we can also use the table diagrams to illustrate the final look of the database. Okay, so now we have 4. Okay, this is also can be illustrated using the diagram. Okay, so I understand that the difficulties here now is to define actually the dependencies. Sometimes we make a mistake, but actually maybe in the first normal form and second normal form we cannot define correctly the key, okay, the dependence, sorry, the partial dependencies, or is that transitive dependencies, but finally usually in the third normal form you can find it all correct. Okay, okay, so this is another practice. Okay, given the dependency diagram, identify the indicated dependencies. So here this is easy, I think, to define that you need to identify the functional dependencies. So this is in the first normal form. The first normal form, you are required to identify the dependencies. So we have to check, okay, but the functional dependency is already given, so we can easily define or indicate that we have 2 types of dependencies, partial and also transitive, exists in this figure. Okay, exists in the figure because for example C1 and C3 is a key, and then C1 is used to identify the C2, and C4 can identify the C5, but C1 is a primary key, C4 is not. So C1 is a partial dependency and C4 is not a partial dependency, but it is a transitive dependency. So you can write down the solution in this way. Okay. So in the rest of the slides given are various more examples. So you can use this to practice yourself the process of database normalization. So remember, we practice first, second, and third normal form. Okay, the idea is to normalize the table database structure. Okay, what to do is in the first step is to define the functional dependencies, and after finding the functional dependencies, you need to identify whether it is a partial dependencies or transitive dependencies. Okay, sometimes we do not have a transitive dependency, so the table in second normal form, when you are removing the partial dependencies, then the table is in the second normal form and third normal form at that moment. Okay, so you can practice uh, with the given exercise. Okay, and then again I repeat, in the first normal form we define the functional dependencies and identify either it is a partial dependencies or transitive dependencies, and then we proceed with the second normal form, that is to remove all the partial dependencies. Remove this one by creating a new table. We split the table. And then finally, if you have transitive dependency, then you repeat the same process. You remove the transitive dependencies by creating a new table. Sometimes a new key will be created. And then at this moment, at this stage, you are at the table will be at the third normal form. Okay, so the rule, the other things that can help you to define the functional dependencies is made an assumption based on the situation. Sometimes more information is given, more detailed information is given, so it helps you a lot to define the dependency. But if the information is not given, so you can make an assumption. Okay, you can write down the assumption. Okay, so with that, please practice, and then if you have any difficulties, then you may contact me. So thank you for this